Hello students. So after completing the problem number 3, let's start with problem number 4 on Leibniz theorem. So here I'm going to take one function, and for that we are going to prove one result with the help of Leibniz theorem. So here y is given as under root 1 plus x upon 1 minus x, and we have to prove that y is equal to 1 minus x square into y1, and then we have to prove the given result. So guys, let's start with the solution. So here, since we have two proofs, I'll start with the first one. So we'll try to prove the first result. Now in the first result, you can see that we have to prove that y as 1 minus x square into y1. It means we have to find out the first derivative of this y. Now guys, if I want to find out the first derivative, there are many ways. One way is I can directly get the first derivative of this function. But as we have learned in lower standard, that is 11th and 12th, that whenever we have a square root, we can take the log on both sides, and then derivative becomes easier. So that is what I'll do is I will take a log on both sides, and then we will find out the first derivative, so that we'll get the y1. And then by doing few adjustments, we can get this result. So let's start. So here I'll take log on both sides. So by doing that, we'll get. So guys, under root is nothing but raised to half. So when I took log on both sides, I got log y is equal to log of 1 plus x upon 1 minus x raised to half. Now log y will remain as it is, and here I can use the property of logarithm, which is log of a to the power b is b log a. So here I'll get. Now guys, here again I can use one more property, which is log of a upon b. So by using that property, we'll get log of 1 plus x minus log of 1 minus x. That is log of a upon b is log a minus log b. So I'll use that property over here. Here I got the simplified function, and now I can find out the first derivative. So differentiating both sides with respect to x. So here we'll get derivative of log y as 1 upon y into derivative of y, that is y1. So I can say the answer is 1 upon y into y1 for LHS. Next, for right hand side, 1 by 2 is a constant, and then derivative of log of 1 upon 1 plus x. So it is 1 by 2 as it is. Derivative of log of 1 plus x is 1 upon 1 plus x into derivative of 1 plus x, which is 1. Then guys, middle sign is minus. So here I'll give the negative sign. And the derivative of log of 1 minus x. Now it is 1 upon 1 minus x into the derivative of 1 minus x. And guys, the derivative of 1 minus x is minus 1. So that minus and minus will become plus. So I'm sure you know the formulas of derivative, because we require derivative maximum times in the successive differentiation. So if you are not thorough with the derivative, guys, I have one video on the derivative which I did for the diploma students. So you can go through that derivative video, revise all the formulae, and see how I have solved the basic sums based on derivative. So the same formula I am using over here. So here I got the derivative. Now we'll do this simplification here to get this result. So as I want this result, so for that I'll send this y to the other side. So here I'll say y1 is equal to y by 2, and here in the bracket I can find out the LCM. So here we will get by cross multiplication 1 minus x plus here I'll get 1 plus x, and the denominator will give us 1 plus x into 1 minus x, which is 1 minus x square. Now guys, here we can cancel this positive x with the negative x. We'll get 2, and that 2 will be cancelled with this 2. So now I'll send this 1 minus x square to the other side. So we will get 1 minus x square into y1 equal to y. And guys, if you observe the question, then we have proved the required result. So by doing this, I got the first result. Now let's start with the second result. So here I have to prove the second result. Now before starting, let's observe the question. So here the highest term is yn. It means I have to find out the nth derivative. And if you observe, then the lowest term of the derivative is yn minus 2. So guys, now it's something tricky, because whenever we find out the n derivative, we get the yn term, or we find out the y of n plus 1 derivative or n plus 2. That is the first and second derivative after the n derivative. and these all things are possible due to the Leibniz theorem. But here if you observe, then we have to find out the n derivative, and then we have to come back to find out the n minus 1 derivative and the n minus second derivative. So how to do that? So guys, don't worry, what we'll do is we will first find out the nth derivative by using the Leibniz theorem, and then to get this result we can come back. So accordingly, I'll find out the nth derivative of this function. So here, as you can see, it is 1 minus x square into y1. It means it is in the form of u into v. So it means to get the nth derivative of this function, I can use the Leibniz theorem. So guys, here on the screen you can see the Leibniz theorem. So accordingly, if we have a format u into v, then we use Leibniz theorem, and I've already used this theorem in the previous 3 problems. So I'm sure that you know that theorem very well. So what we do is we consider one function as u and other as v. So which function is u? So the function for which the nth derivative is possible is called as u. So here in my case, y1 will be u because the n derivative of this function is possible, and the other function is v because for this function n derivative is not possible. Here we can get the 2 or 3 derivatives. So let's start. So accordingly, the first term will be un. So it means n derivative of this. So n derivative of this is y of n plus 1. Then we have v. Okay, we also have nc0. Guys, nc0 is 1, so I'll not write that. Then v is this term, so I'll write it as it is, that is 1 minus x square. Then we have middle sign as plus. Then we have nc1. Guys, nc1 is n. Next we have to find out u of n minus 1. Now what is u of n minus 1? It is one derivative previous to un. So this was the nth derivative. Now we'll take one previous derivative, that is y of n. So what I'm doing is I'm just subtracting this by 1. So I got yn. Next we will have v1. You can see here we have v1. v1 is the first derivative of v. So guys, here v is 1 minus x square. Its first derivative is negative 2x. Plus we have nc2. Now nc2 is n into n minus 1 upon 2 factorial. So this is the value of nc2. Next we have u of n minus 2. Now u of n minus 2 is again one derivative previous to u of n minus 1. So this is the value of u of n minus 1. The previous to this is y of n minus 1. Next we have v2. v2 is the derivative of v1, which is negative 2. And guys, here we'll stop because in the next step we have to find out the derivative of minus 2, that is v3, and the derivative of minus 2 is 0. It means the next term will be 0. So we'll not write the next term. So here we'll stop the Leibniz theorem. So we got the expansion or the derivative or the nth derivative, I would say, for this 1 minus x square into y1. Now similarly, I'll find out the n derivative of this y, and guys, we all know it is y of n. That's it. Now we'll simplify this. So 1 minus x square, y of n plus 1 as it is. Now this term is yn. I'll take it to the left hand side. That will be subtracted, so that will become minus. And already we have a negative term. So from these two terms I can take minus n outside. In the bracket, from here we will get 2nx, and if I take this term to the other side, I'll get plus 1, and yn is outside. And then here 2 and 2 can be cancelled. This is minus n, so minus n here. In bracket, n into n minus 1 into y of n minus 1 equal to 0. So now guys, if you observe this answer and if I compare it with the question, then it is not matching with the final answer, because in the final answer we want first term as yn, and here we got the first term as y of n plus 1. Similarly, the last term is y of n minus 1, but in the question the last term is y of n minus 2. It means if I want to get this answer which is asked in the question, what I have to do is, this is the nth derivative which I got due to the Leibniz theorem. So from here I have to find out the n minus 1th derivative. So here I'll say n minus 1th derivative is given by. So what I'll do is, I will take n minus 1th derivative of this equation. So accordingly, what I'll do is, wherever I have the nth derivative term, I'll reduce it by 1. So here I have y of n plus 1. So by taking n minus 1th derivative, this will become y of n. So I will get 1 minus x square into y of n. Next here I have n, that will become n minus 1 because I'm reducing it by 1. This will be reduced by 1, so this will become n minus 1. So we'll get negative 2 of 2 into n minus 1 into x plus 1 into y of n minus 1. Next, here if I reduce this by 1, I'll get n minus 1. Here I'll get n minus 2. And here we'll get n minus 2 if I reduce it by 1. So that will be. And now guys, if you observe this answer, or if you compare that answer with the question, then it is exactly matching. So here we have proved the result. So guys, this was the different type of numerical where to get the answer we had to find out the n minus 1th derivative after finding the n derivative by the Leibniz theorem. But remember, this kind of questions can come in the examination, and hence I have taken such type of questions so that you all will be able to solve such type of numerical in the exam. So guys, keep watching our videos. Here I stop this video, and tell your friends to subscribe to our channel because they can also get such wonderful videos of engineering mathematics and other subjects of engineering through Ekeeda. Thank you very much.